Hello everyone. In this video, I would like to discuss about the concept of duty cycle. So understanding this concept is very much important because it helps you to deal with any of the power electronic circuits which are using these controlled switches like gate triggered switches, example like MOSFETs, IGBTs, which are used in some of the power electronic circuits quickly to note some of them are like inverters, DC-DC converters like buck boost converters. So many other circuits uses these IGBTs and MOSFETs in controlling methods of the power electronics. Okay, so we might have a some concept about duty cycle, but in this video I'll be showing the visual graphs through the simulation, like varying the duty cycle, how it is affecting the output voltage in a circuit. In a simple circuit, I'll take a simple circuit as example and show you what is the effect of duty cycle in the output voltage. Okay, so by the end of this video you will be having a clear understanding of this duty cycle concept and the importance of it through the visual graphs, so you will have a better understanding. So before getting into this concept of duty cycle, let me discuss about this time period. Okay, this is also important to understand this concept, duty cycle concept. So I'll quickly draw a few graphs to discuss this concept. So let us consider these are the some of the signals. Let us consider these are some of the signals or waveforms. I'll draw a sawtooth waveform. So what is time period? Time period is nothing but the time that is required by the wave to complete one cycle of its repeating sequence. Okay, if you see clearly, the wave is started repeating from here and again started repeating from here. So the time that is required or the time taken by the wave to complete one cycle of its repeating sequence, this is the time period for this sawtooth waveform. If I draw a triangular waveform, so again the wave started repeating after this, again after this, like that. So this is the time period for this. And if you consider a sine wave, similarly this is the time period because the cycle started repeating after this. And some other example, if I consider now, what is the time period for this waveform? It is this is the time period because you see the wave started repeating after here. So this is a simple concept of time period. I have given this concept because it is important to understand the duty cycle. Now let me draw quickly a simple circuit for a better understanding of this duty cycle concept. So I'll take a DC circuit. Okay, DC circuit with a switch and a R load and a DC voltage source. This is V in, R load and V out. Okay, here is a switch. For explanation sake, just consider this as a manual switch. Okay, which means you are operating this switch manually, switching it, turning it on off manually. Okay, as you know, when the switch is closed, what is the voltage across the load? I hope you can guess it. It's a simple, right? When switch is closed, you see the output voltage is same as the input voltage, right? Switch is closed, V out is nothing but V in because load is in parallel with the source. Now when switch is open, what is the voltage across the load? Can you guess? Yeah, the voltage across load is going to be 0. Why? Because let me write it down here. The voltage across load is going to be 0 because when switch is open, there is no closed path for the current, right? All the voltage that you are applying V in, you can see it in this across this port. So the current is 0 and V out is nothing but I into R. So current is 0. For any value of resistor, the output voltage is also going to be 0. Now let us say that you are operating the switch manually or closing this switch for t on of time, closing this switch for t on of time and switching turning off this switch for t off of time. Okay, and t on plus t off is t. I hope you got it right. You are turning on the switch for T on and turning it off for T off, and you are repeating the sequence again with the same time period. So the time period is T. If I put it in a waveform, it is going to be like this. So you are switching it on for T on of time and switching it off for T off of time. Again the sequence is repeating. So this is going to be your time period, and so on. So this is your voltage, or pulse you say. Now this is the concept right now. What if you're trying to understand what is going to be the V out, I'll take a different color here. Yes, now if you are trying to derive the formula for V out is going to be average value. We are deriving the average value. So V out is going to be 1 by T integral of 0 to T. Yeah, this is V out. I forgot to mention here, this is V out here. So V out is going to be 1 by T integral of 0 to T V out dt. Now if you further split this, it is going to be 1 by T of integral 0 to T on V out dt plus T on to T V out of dt. Now as we already know, from 0 to T on, when switch is on, as we saw, V out is going to be V in. This V out is going to be V in. When switch is off, V out is going to be 0. So V out average is going to turn out to be like this, 1 by T into this whole component is going to be 0, and this is T on into V in, right? So I'll highlight. Okay, V out is finally going to be T on by whole time period into V in. I'll take another color again here. Okay, now V out is going, like from the derived formula, it is T on by T into V in. So this component which you are seeing here, this like this formula, this is called the duty cycle, which means duty cycle is nothing but how much time the switch the pulse is active for the whole compared to the whole cycle. Okay, compared to the whole time period, how much time the pulse is active, which it is nothing but T on by total time period. Okay, now this T on by T, you can write this as K. Now let us replace this switch, manual switch which we have drawn, that with the MOSFET. Okay, I'll erase this manual switch here and replace that with the MOSFET. Yeah, I've drawn a MOSFET symbol over here. So we are replacing that manual switch with the controlled switch or the automatic switch. Now because see, in the practical applications that is not possible, we can't be everywhere to turn the switch on and off, right? It has to be automated and controlled through the gate signals. This is the gate. Consider this as 10 volts and load as 1 ohm. Now if duty cycle D or K, whatever we consider this as, duty cycle is 100%, then what is going to be the V out? V out is going to be 1 into V in. V in is nothing but 10 volts. So V out is nothing but 10 volts here. So when duty cycle is 100%, which means you are turning it on for whole time period. This whole time period you are turning the switch on. Then the V out is going to be 10 volts. Now let us say if duty cycle is 50%, what is going to be the V out? 0.5 into V in, nothing but V out is 5 volts. Similarly, for 25% duty cycle, V out is going to be 2.5 volts. So by varying the duty cycle, you clearly see that for a fixed input and fixed load, you see that the V out is varying. with respect to the duty cycle. So we use this concept in all the in most of the controlled circuits like inverters and DC-DC converters, this concept to get the variable output voltage or to have a fixed output voltage for varying input by forming some closed loop circuit. Okay, now let me draw a graph here for this duty cycle to have a better understanding. So this is our pulse, gate pulse, and let us consider this as V in and V out. Gate pulse, first of all we'll consider 50% as a duty cycle. Okay, this is 50% duty cycle. Now V in is constant, V in is constant 10 volts. Now for 50%, when switch is on, you see output sees the voltage of 10 volts. When switch is off, there is no volt. Again switch is on, 10 volts, switch is off, no volt, like that. Then our average is going to be, for 50% duty cycle, average comes around 5 volts, right? I hope this is clear. Now if you change, I'll take another color. Now if you change the duty cycle, to 75%, okay, 75%, you automatically see the change in output voltage as well. Not there, something like this. Okay, you'll see the change. I hope you are getting the concept. Duty cycle. Now let us get into the simulation where you will see the circuit, this particular circuit that I was telling. We will simulate it and see the results, how the graphs are and for different duty cycles. So this is the circuit which I have simulated to explain you the concept which I have explained earlier with this circuit. This is a 10 volt input DC source, and this is the MOSFET which is being triggered by the pulse generator. And for the pulse generator, as you see, the time period is 1/100, which means the hertz or the frequency is 100 hertz, and pulse width or the duty cycle I have considered as 50%. And also I have added a current sensor to see the current or the measure the current in the circuit. Resistor is the load here, which is of 1 ohm. Okay, resistor is 1 ohm, and I have connected a voltage sensor across the resistor to see the output voltage. As you see, output voltage V is given to a scope to view the results, and this is the gate pulses. One is the gate pulses I have given to the scope voltage, and the other one is the current which I have taken from the current sensor. And lastly what I have done is that I have taken the average value of the output voltage to see to have a visual display. I have connected this to the display, also taken a scope, taken a signal from that to view on the scope the average value. Let me explain it through the graph now. I have given the pulse width as 50%. I'll run this, and you will see the average value changing now from 2.475 to 5. As we have seen the calculations earlier, for 50% of duty cycle, the average value has to come around 5 or 4.9. It is coming around, which is close. Okay, now let us see how the graphs are. Let me minimize this for it. Wait, I'll adjust it according to the screen size so that you will have a clear view. Okay, I hope you have a better view now. Right now, what is the duty cycle that we have given is a 50%. The gate pulses, you see, for 0.01, which we have given the time period, for half of the time the duty cycle is on, and for other half this is off. You see, right? For again it is on off, so 50% is a duty cycle, clear from the gate pulse. Okay, now the voltage, which is the output voltage, is in similar fashion with the duty cycle. Output voltage is, you see, 10 volts. Okay, which is the input voltage that you are seeing, 10 volts, on off again. as we have already discussed. Current, how much should be the current? For resistor of 1 ohm, voltage of 10 volts, current is I equal to V by R. So current is going to be 10 amps. You see the current is 10 amps. And the average value of output voltage is, it is coming around 5 volts. You might get confused seeing this graph over here, but if I hide this and just give the average value, this is coming around 5 volts. So output is a 5 volt. Let me also tell you that this is not the correct form of, or correct output voltage pattern which is taken by any load, because loads are not suitable for this kind of waveforms. They need a more smoothened waveform or more conditioned waveform, right? For that we will add L and C filters in the circuit, but just for explanation sake, or as far as the duty cycle concept is concerned, I haven't put any filters in the circuit, just to have understand this concept of duty cycle. But as I was telling, that loads are not preferred for operation with this kind of output voltage. They want more smoothened waveform, like this kind of waveform, DC voltage. Okay, now what I'll do is, like, I'll change the pulse width to 25%. Now what you should see here is something around, wait just a minute, I'll run the scope. What you'll see is around 2.5, and similar should be seen in the scope. See, 25% become the duty cycle now. 25% it is on, 75% it is off again. Similar the fashion is for output voltage. Now what is average value? It should be around 2.5 volts. And if you see the current remains the same. Current is around 10 and again 0. It follows the same as voltage. Okay, because the resistor is of 1 ohm, current I equal to V by R, it is also 10 amps. Now I'll change the duty cycle to 75%. Again run the, see, 7.5 should be seen, it is close to that. Also you'll see the output waveform for that. See, now signal is on for 75% of time and off for 25%. Again on for 75%, off for 25%. Similarly you see the output voltage. Similar is the fashion of current, because see, current is in phase with the voltage because it is a resistor, right? As this is resistor, you see current following the voltage, and the average value is coming around 7.5 volts. Now what I will do is, like, I'll change the resistor. I'll change the resistor to 10 ohms now, and run it again. Now you'll see the difference in the current. 10 by 10, I equal to V by R, 10 by 10. So current is going to be around 1 amp. I'm opening the scope. You see, now if I highlight the current, how much is the current? It is around 1 amp, right? I hope you are getting this concept. Now let me, okay, I have put this as 10, right? Let me change the input volts to 20 volts. Okay, yeah, I have changed the input volts to 20 volts, and the duty cycle is I'll change this again to 50. Okay, 50% is the duty cycle. Now I'll run it. How much you should see here? You should see here around 10 volts, right? So it is similar to that. Now if you look at the waveforms, see, the output voltage came around 20 like that, and the gate pulse, which is same, we did not change the gate pulse, it is 50% is the width, and we have kept the amplitude also same, we did not touch the gate pulse amplitude at all. And now the current is how much? It is like 20 is the input and output is 10. 20 by 10 is 2, right? So it is around 2. I hope the concept is clear, and if you want more explanation on this circuit or any other circuit, please comment down. I'll give a detailed explanation of the circuits, and also I'll be explaining R, RL, RLC loads, RC loads in the future upcoming videos. through these visual graphs, so you'll have a clear understanding of the concept. Let me show the average value here. Average value came around 10, which is 20 like duty cycle into V in, right? Duty cycle is how much here? 50. 0.5 into V in is 20. It's going to come around 10. Okay, thank you for watching this video. I hope this is very much helpful for you, and if you find this helpful, please comment down and ask for any videos that you want me to make, and if you find that is going to help you. Thank you.